Hello everyone! In this video, we will learn about set, relation, and function. Before we start, let me introduce myself. My name is Ketut Asri Dewi. You may call me Laksmi. My last name is 0, 7, and 6. I'm from class 4C, Mathematics Education. Okay, the first, we learn about the concept of set. Let me ask you something. Do you have a contact list on your phone? Inside your phone, you probably have many names like Anna, Budi, Citra, and Dewa. Now, instead of thinking about each name separately, we see them as one group called contacts. So, your contact list is actually a collection of names. In mathematics, when we have a collection like this, we call it a set. And each name inside the list is called an element of the set. So, based on this idea, a set is a collection of well-defined objects. We can write this set like this. Now, remember, not every collection is a set. A set must be well defined. For example, student in class 11 is a set, but smart students is not a set because it is not clearly defined. The next, examples of set. We define set B as battery levels above 50%. This means any battery level greater than 50% belongs to set B. For example, 60%, 80%, and 100% are included in set B. So, we write 60% belongs to set B. 80% belongs to set B and 100% belongs to set B. On the other hand, battery levels like 20% and 50% do not belong to set B because they are not greater than 50%. So, we write like this. Okay, next, 3 ways to represent a set. The first is descriptive method. In the descriptive method, we describe the set using words. We explain what kind of elements are included in the set. Next, in the roster method, we list all the elements of the set inside curly brackets. In set builder notation, we describe the set using a rule or condition that all elements must satisfy. These 3 methods represent the same set, but they are written in different ways. Now, let's learn about types of set. First, a null set is a set with no elements. For example, we can write A equals empty set, which means 3 are no elements inside it. Second, a universal set contains all elements in a given context. For example, U equals 1, 2, 3, 4, and 5. This means all elements we are discussing are inside this set. The last, a subset is a set whose elements are all contained in another set. For example, A equals 1 and 2 is a subset of B equals 1, 2, 3, and 4. This means every element in set A is also found in set B. Now, let's learn about set operation. Set operation help us to understand how sets interact with each other. First, we have intersection. The intersection shows elements that are in both sets. For example, set A and set B both contain the element 3. So, the intersection of A and B is 3. Second, we have union. The union combines all elements from both sets without repetition. So, the union of A and B includes 1, 2, 3, 4, and 5. Third, we have difference. The difference shows elements that are in one set but not in the other. For example, A minus B gives us 1 and 2. Finally, we have complement. The complement shows all elements in the universal set that are not in set A. So, A complement contains 4 and 5. This operation helps us compare and analyze sets more easily. Now, let's look at an example. We are given two sets, set A and set B. Our task is to find the intersection and the union of these two sets. And solution, the intersection includes elements that appear in both sets. So, the intersection of set A and set B is the set containing 4 and 8. The union includes all elements from both sets without repetition. So, the union of set A and set B is the set containing 2, 4, 6, 8, 10, 12, and 16. Now, let's see how sets are used in real life. Imagine a restaurant menu. All menu items form the universal set S. Some dishes contain peanuts and they are grouped into set B. Now, a customer has a peanut allergy. So, we need to find which foods are safe, right? Now, to solve this, we use set difference S minus B. The result is fried rice, fried noodles, and fruit salad. These are the safe menu items. Okay, next we learn about relation. The relation of set A to set B is a rule that connects each member of set A to member of set B. This is relationship presentation. There are three ways to represent a relation. First, a row diagram, sequential couple set, and Cartesian diagram. Now, let me explain the example on this slide. We have two sets. Set C contains the numbers 2, 3, 4, 5, and 6. Set D contains the number 0, 4, 5, 6, 7, 8, and 9. Next, we define a relation between elements in set C and set D. The pairs in this relation are 2 is paired with 7, 3 is paired with 7, 4 is paired with 4, 5 is paired with 6, and 6 is paired with 0. First, a row diagram. In the arrow diagram, we draw arrows from elements in set C to elements in set D. Each arrow shows how one number in set C is related to a number in set D. For example, the number 2 points to 7. The number 3 also points to 7, right? The number 4 points to 4. The number 5 points to 6. And the number 6 points to 0. This diagram helps us see the relation visually. Okay, number second, sequential couple set or order pairs. We can also write the relation as a set of order pairs. The relation is written as R as R is equal to the set of order pairs 2, 7, 3, 7, 4, 4, 5, 6, and 6, 0. Each order pair shows the first number comes from set C, and the second number, this, comes from set D. Now, I will explain about number third is Cartesian diagram. The visual is like this. Okay, next we explain about a function. Function is a special form of relation between two sets. A relation is said to be a function if each element in set A or domain is paired with exactly one element in set B or codomain. Okay. For example, we have set A contains the number 1, 2, and 3. And set B contains the number 1, 2, 3, and 4. Next, we define a relation between set A and set B. The relation is 1 is paired with 2, 2 is paired with 3, 3 is paired with 4. Why is this called a function? This relation is called a function because each element in set A is paired with exactly one element in set B. So, one input has only one output and no element in set A is paired with more than one value. That is the main rule of a function. Okay, let's see this diagram. In the arrow diagram, we can see the number 1 points to 2, the number 2 points to 3, the number 3 points to 4. This shows how each element in set A maps to one element in set B. Next, sequential couple set. The function can also be written as a set of ordered pairs. R is equal to the set of ordered pairs 1, 2, 2, 3, and 3, 4. So, this example shows a function because each element in set A has exactly one pair in set B. And this is the visual of Cartesian diagram. Okay, next, function terms. A special relation where every element in the domain has exactly one partner. A relation is called a function if it meets these two requirements. First, every member of the domain must have a partner. Second, every member of the domain must have exactly one partner. Okay, next, types of function. The picture number 1 is injective function. Picture number 2 is surjective function. And the last picture is bijective function. Injective function or 1 to 1 is each input has a unique output. Surjective function is every element in the codomain is mapped. And bijective function is 1 to 1 and onto at the same time. Okay, now let's solve a problem about function. We are given a function f of x equals to x plus 1. To find the value of the function, we substitute the value of x into the formula. First, f of 2 equals 2 times 2 plus 1, which is 5. Next, f of 4 equals 2 times 4 plus 1, which is 9. Finally, f of 6 equals 2 times 6 plus 1, which is 13. So, these are the outputs of the function for the given inputs. Now, let's look at a real-life problem using function. A taxi charged $5 as the initial fee and $2 for each kilometer. We can write this as a function f of x equals 5 plus 2x, where x is the distance in kilometers. To find the cost for 3 kilometers, we substitute x equals 3. So, f of 3 equals $11. For 5 kilometers, f of 5 equals $15. This shows how function can be used to calculate real-world cost. Okay, then the last is conclusion. First, sets help us organize and classify information clearly. Second, relations describe how elements are connected. Third, functions provide a consistent rule to link inputs and outputs. And the last, this concept form the foundation for solving real-world problems mathematically. Okay, that's all about my presentation. Thank you for watching and see you.